Can everyone hear me all right? Cool. So my name's Alistair Hann. I'm the Chief Technology Officer at Skyscanner. First of all, who are we? Well, we're a company based up in Scotland. This is the picture I took from Arthur's Seat looking back down on Edinburgh. Our office is somewhere kind of left of the castle there. And it was a business founded by 3 software developers who were fed up with trying to plan their trip skiing. They were sort of trying to work out which airlines flew on which routes, what the best prices would be, what time they should go, and there weren't really the tools available to do that at the time. It was about 10 years ago. There were more and more budget airlines arriving, and they were just really frustrated. And what was kind of a personal spreadsheet turned into an idea for a business, and the guys bootstrapped it up from there, employing more and more people. And what that means in terms of the product today is that the way I like to think about Skyscanner is there's a stack, and at the bottom there's lots of disparate information about travel. So there's traditional airlines like British Airways or US Airways. There's lots of budget airlines, and there are also these business things called online travel agents. And what online travel agents do is they're like a high street travel agent, so they'll let you buy different things from different suppliers. It's not like buying from an airline direct, as if you went to Ryanair.com. And there's lots of disparate information out there, and we basically search those data for people, index them, and let people find what they want without having to be a travel expert and focus more on what they're going to do when they go on holiday. People consume those data through a number of different platforms. We have our main website, and that was the main way people searched on Skyscanner for many years, but we now have our mobile apps. There are about 20 million downloads of those, over 20 million downloads of those. So there's iPhone, Android, Windows Phone, BlackBerry, and others. And then we have a mobile website for people. And what I want to talk about today is a journey of getting to that point. So this is a graph of sessions from 2004 until the end of last month. And so you can see this kind of being this exponential growth in the number of people visiting our site. And that results in about 120 million searches a month that we currently run. And not only do we have to scale according to the number of users, as more users come along over time, they tend to generate more data per user. So as we add more suppliers into the site and there are more airlines available, actually the growth in data is faster than the growth in searches. So it's even steeper than that curve. Fortunately, the revenue line on that curve also goes up, so we can keep paying engineers and to build servers and make profit and things like that. So what actually happens when someone runs a search? So there are basically a couple of APIs that principally power the application. One of them is what we call a Browse API, and that enables people to do flexible searches. So things like, I want to go from London to Australia in March, and it'll look across all the different things and tell you how much it costs to go to each city or how much it costs to fly on each day. So it's unique functionality which lets you be really flexible. But the other thing we do is specific searches, which is more like what other people do. So that's, you say, I want to go from this city to this city on these dates. So when a user does that on the website, what happens is, here I've got a search from Edinburgh to Nice. It's kind of convenient because I think Amadeus came from Nice and they're next. It was unintentional. And outward date and inward date. And then the search results someone would get on the website say, include 2 important things, one of which is you've got lots of different airlines there, but also you've got the prices according to different airlines. And what I'm going to talk about is how that search works and what the cache is that's behind it and how we've had to scale it up with that sort of user and search growth over time. So the first thing that happens when a user comes to run a search is we have to determine what websites are relevant. So if you're running a search from London to Nice, you're probably not going to want to look at a budget airline in Ecuador. So we have lots of timetable data that we need to process, and we need to look at what people can actually buy, what's available, can you combine these 2 flights, is there enough transfer time. So there's a lot of complexity in that. And also, we run in over 30 different languages, and we actively manage over 25 markets. So we need to make this experience as local as possible to people. So not only is the destination website available in their language they speak, can they purchase in the currency they use, but are they the brands they recognize? That you need to make sure that if someone's searching in Russia, you show them a Russian travel agent rather than a Chinese travel agent, which they may have no affinity to. So it's about customizing and localizing that experience for people so it feels like something local to them. So once we determine which websites we're going to show, there's a chance that we've already got some of the data already. So we get it to about 10,000 concurrent users on the website at any one time, and there's a chance of having a cache hit. The chances aren't necessarily very high because the search space in travel is enormous. So there are about 5,000 airports in the world that have commercial flights, so that's 25 million possible routes. And you can travel in and out on all sorts of date pairs, so that's 25 million times 365 squared divided by 2. So there's trillions and trillions of different bits of data that you could have. But having said that, there will be very popular routes like London, New York, and you'll get a cache hit on those. And if you can serve data to a user from a cache, there are benefits to them because they get a faster response, benefits to us because it's less load on our back-end systems, and also it's good for our partners because there's less load on their systems too, and ultimately on the airline systems, which have to handle things such as ticketing, and they're the things you check in at the airport. So the cache is pretty important to us. If something's not in the cache, then we'll go and fetch those data from data collection services, so we'll connect to an airline or an online travel agent's API and get back the data to service a query. The data may not be perfect. There could be things missing from it, such as the duration, taxes, fees, credit charges. So we clean up and augment those data. We'll throw them back in the cache for future use. And finally, we'll give them back to the user. And the great thing about having this sort of service-oriented architecture for us has been that it enabled us to build all those mobile applications with teams who didn't have to worry about the complexities of flight search, and we very easily managed to add those, and they can function on building sort of awesome UI and really good user experience and just really nice apps. So I'm going to talk about scaling that price cache in the middle. So that's the thing that gets called on every single search to see, have we seen this already, and we end up writing to it. So there's a lot of writes going in there and a lot of reads. So when we started out, almost 10 years ago, it was pretty easy to just have that in a relational database. It was the obvious tool of choice. You just say, okay, well, we've got some data, we've got SQL Server, let's put it in there. And initially it was normalized a bit, and actually we denormalized it later on because that was going to give us a bit of performance enhancement, and denormalization seemed to be the answer to many of our woes. But eventually that wasn't really going to keep scaling because you have to buy bigger and bigger boxes, and there aren't many options. So the first thing we did then was to actually scale out the reads and the writes. So the front-end application would start reading from a display layer database of the flight cache. So these are still SQL Server instances, but they contain a sort of a read-only copy of the flight data. So there's no longer read-write contention there necessarily. And whenever users produced more data, that data was being put on queue tables within SQL Server, which would then get pulled together in a single place by this thing called a quote processor. And then it would produce a single view of the data that was seen on all the servers and replicate it out to the front layer. So basically, we could read from this top layer, and we could scale out that top layer quite easily by just adding more nodes in terms of reads, and by sharding the data across multiple, so that it was run on different quote processors, we could sort of scale the back end as well. So it was okay, and it enabled us to grow sort of more than tenfold on this scaling side of things. But you're still running into some issues. And unfortunately, the one we introduced in this design is this idea there's actually a latency between data being generated by the application at the front and then it all going down to the quote processor and back up to the top. So now you've got a danger that when a user comes along, they'll hit that front-end node, and then they'll have generated some data, and if they reran the search immediately afterwards, they could get a different experience because the data hasn't gone all the way around, so they're not going to hit the cache of their results. So to mitigate that, what we did was we introduced memcached on each of the front-end nodes. So it was a local in-memory cache, a key-value cache, that basically held a copy of the data that the user had just seen. So this is great. So it held the data long enough for the data to make it through the other path, and everything was fine, except, amongst other things, we introduced a dependency on sticky sessions. So now a user needs to be attached to a particular web node for the duration of their search, which isn't terrible. Like if that web node goes down, you can just bounce them off to another node and the search restarts. Maximum, you just elongate the duration of a user's search. But it's not ideal either. So it was a good solution. It scaled through many levels, but this system is already getting pretty complicated, and there's quite a lot of pressure on the databases. We decided to try and reduce the write pressure on the front-end databases by moving the queues off from the queue tables into RabbitMQ. So now when the searches were run, the data would be saved onto RabbitMQ and then loaded from there into the back-end database. So now, at this point, the only thing writing to the front-end layer is the quote processor sort of replication of that copy of the master data from the quote processor. And we've got rid of the latency, and it's stable, it scales, but there are some, as I said, you've got the sticky sessions, you've got increasing licensing costs, SQL Server licenses can get very expensive when you've got a lot of them, or you've got them on very powerful boxes. And we ended up moving to Fusion IO cards and things like that to keep scaling those databases. In terms of actually the volume of things it's going through, so this big denormalized table is taking up about 270 gigabytes. It's actually a view over 2 tables. There's another 1/4 terabyte of indexes on it, and it's got a few billion rows, and we're writing at it at 2,000 new rows a second, inserts or updates. So it's fairly busy, and we're reading from it too. So as you probably guessed, none of these solutions really met what we wanted. So what we wanted was something that was consistent. So if a user hit any of our nodes, they'd be able to just they just get the same data as if they, regardless, and you didn't have to have them sticky to that node. We wanted persistence, so if we wanted our data to survive a process stopping, so we couldn't just use memcached as the overall cache because that wasn't going to remain stable for us. Wanted it to be really fast in terms of I/O. We don't want to keep having to buy these big database servers. We'd like to be able to scale out in a predictable way and know that we can just continue scaling out the application as traffic grows. It would be nice to have elasticity so we can take nodes in and out of the cluster according to what we want to do. And it would be great to get rid of that whole quote processing loop because it's a nightmare to maintain, and lots of DBAs are pulling their hair out just trying to keep that running as the data volumes get bigger and bigger and there's more and more data to push forwards and replicate. So as you probably guessed, bear in mind at the Couchbase conference, that what we decided to do was to start using Couchbase. But we took a sort of softly approach because this cache is pretty core to our business, and if it goes down, the resulting effect on us is pretty significant. We'd have to downgrade our service a lot. So the first thing we did was actually use it to replace the memcache cache at the front of the application. So that memcache, so the memcached cache was now persistent. So that means it gets to see exactly the same number of reads and writes as it would do if it was the primary cache, but we've still got the SQL Server cache as a backup. And we can start off with a small cache duration as we had initially and eke that up slowly until it basically becomes the primary cache, and we can run with that for a long time. And then eventually you get rid of all that legacy quote processing system and you just have your distributed Couchbase cluster. So what do the documents look like that we have in there? So in Skyscanner we use Thrift. For those of you who are not familiar with Thrift, Thrift's something that was developed at Facebook. It's a binary serialization format. It was developed by the guys who produced protocol buffers at Google. You can define a document in this sort of language, in this sort of this format, which is language agnostic, but it will then generate your classes for you in the languages you use. So we're mainly a C# and Python shop, and this enables it to be very easy to build an interface between different languages and just pass data between them as binary data. In practice, we've ended up zipping these objects. So although they're binary objects, they do contain quite a lot of strings and there's repeated data. So you'll see in that structure there's something called a list of transport quotes. Each of those quotes will contain information about airports and locations. So there's quite a lot of repetition in those data, and by zipping the documents before we put them in Couchbase, we considerably reduce the amount of storage we're going to require. I should say that this application was a 1.8 application, so we weren't able or interested in the MapReduce side of things for this, so it didn't matter that there were zip binary objects. It was just key value, and it lends itself to key value because it's basically these are the data for this pair of airports, this pair of dates, and this website. So here's some screenshots of the production setup we've got. This was during a fairly quiet time yesterday morning, so they're not the biggest numbers we can dig out. And there's 1.5 terabytes of RAM in the cluster spread over 6 boxes. We've got multiple buckets running on them. So we've got some Couchbase buckets, which include the quotes data, but we've also got some session state there about the search that people are running, and some web caching of content for web pages as well. And then we've got some memcached buckets we use for other things, where just to support memcached. If we go into the details of this particular quotes cache, so I guess we're rocking along at about 1,500 ops per second then, but I mean, we push it quite a lot higher during busy times. So creating 780 documents a second, getting over 1,000 documents a second, but we put it through a bit more grief than this at busy times. In terms of what we run it on, we had a choice when we started out about whether we would run it on virtual servers or on dedicated servers. So the Couchbase licensing model is one of per server licensing, so it's cheaper if you have fewer boxes. Sorry guys, won't invite me back now. So it's cheaper for us to have fewer boxes with more memory on them. Having said that, we've had to balance that against our VMware licensing, which means that if you have something that's got an awful lot of memory and you're not using that much CPU, it's not particularly good value otherwise. So it was a trade-off between either so either way we're going to have as few servers as possible, but equally we wanted to do it in a way such that we didn't incur lots of VMware costs. So dedicated boxes were going to be quite a lot cheaper for us, and we potentially get some benefits elsewhere. I mean, nearly all of our web servers are just running on a bunch of ESX hosts we have, but we did that here. After we started using it, there's one thing, which is we wanted to be able to scale the size of buckets dynamically, and in order to do that, they need to be persisted to disk. So we ended up kind of having to persist things to disk that we wouldn't have persisted otherwise, and some of these data had an awful lot of churn. So this search session state data, it gets polled a lot by users, and it gets updated as more data come in. And so there was an awful lot of sort of churn and thrashing, and it was previously on a SAN, and basically we had to move it to local SSDs on the device, but that solved the problem fine. I don't think that's a typical use case for Couchbase customers. I think normally people are limited by CPU, but we had oodles of CPU sitting around, so it was disk I/O that was our limitation there. But we got the SSDs and it was fine. We operate with one replica copy of the data. It's not the end of the world if some of these data go, because we can just get them again from our partners. So we don't need to be sort of incredibly uptight about it. But then again, we do want to be able to take a node out of a cluster for maintenance and not sort of decrease the quality of our cache. Early on, we had a few issues taking nodes in and out of the cluster. One of the issues was that basically we'd having problems failing over the nodes, but that was due to a bug that's now been fixed in Couchbase 2, apparently, so hopefully that's okay now. One of the limitations we face is that we're stuck a bit with how many buckets you can have per cluster, because the more buckets you have per cluster, you can get some level of performance hit. We find 4 to 6 works fine, but I guess ideally we'd have I prefer the idea of having lots of siloed buckets for different bits of applications rather than just using keys to separate things out. So as a result, we've got a tendency to put things on different clusters, but that, once we get beyond that 4 or 6 bucket limit, but that also helps separate the clusters, so in case there is some sort of failure or event that hits the whole cluster, the other different web applications aren't affected. So we do use the buckets, but we're a bit limited in that scope. As you can see, we use the monitoring console. One of the limitations we find with that is that you can't, at least in the version we're using at the moment, you can't change that's kind of a sysadmin console, so you can create and delete buckets, and it'll be quite nice to be able to view what's happening in the cluster at the same time, rather than you don't want to be giving a developer who wants to look at how full the cluster is access to take out your entire cache for your website. So the access controls for that mean that we had to kind of duplicate some of the stats, but all the stats are available through the APIs, so you can just pull them into whatever monitoring system you use, and that gives us a good view over things as well. So the next thing I want to talk about is going beyond just using Couchbase as a distributed key value store, awesome though that is, but actually using some of the newer features. And one thing we built recently is a new car hire application that sits alongside our old one. It's sort of dark launched in a limited number of markets at the moment, so it's not seeing epic quantities of load, but it was an opportunity to build something new from scratch and to use Couchbase as the sole data store for everything that was going inside it. It's a similar product to the flights product, so you're searching between 2 places and 2 dates, or if you're picking up and dropping off at the same place, it's 1 date. And what happens when someone runs a search is quite similar. So first of all, we need to work out which websites there are. So in this case, does Hertz have an office at Nice Airport, or will Holiday Autos show a car for this user? The next thing is we need to look in the cache to see if we've got something already, and then finally we live update what we haven't got yet, and then we'll put it back in and return it to the user. So there are sort of 2 types of data. There's reference data and then there's the quotes data. So some of the reference data is information about suppliers and their offices. So it'll be a document like this kind of snippet from one of the documents here, where you've got information about an office. So you might have its opening hours, its geolocation, the code that it uses, what country it's in, etc. But we need to be able to run queries, we need to be able to say, well, what offices are there at this location? So we use the map-reduce views to produce this sort of index such that if we say Edinburgh Airport, you can say, well, these are the websites that support searches at Edinburgh Airport. So we've got views over these documents. We're using the Python Couchbase 2 client, and there's other data in there as well, such as reference data about cars, so we can use that for augmenting the details, so to make sure that different suppliers come back with a car, so you can say what it's like or how many doors it has, whether it's automatic, and enrich the data there. The other thing we do is the actual quotes themselves. So unfortunately, this application's in Python. The first one was in C#. Unfortunately, the smart client isn't available for Python. It's kind of work in progress. And that means that not all the features are available in it. In particular, it doesn't have the multi-get. And what we really wanted in this case was we're being polled to know, we're keeping polling to see if data have arrived in Couchbase yet. So we actually want to be, it's pretty intensive reading and writing. And so we wanted something that's either we can use the same connection across, to keep using the same connection, but unfortunately the Python client isn't thread safe. Alternatively, we want it to be as cheap as possible to create and tear down that connection, but the Python smart client at the moment is a bit heavyweight. So we've had to work around that. Now this is a key value application, so we're able to resort to using memcached. So one of the things that comes included with Couchbase is the Moxie server. So we have what we do in the application is what Actor 2 is doing in this diagram. So it goes to the Moxie proxy, and basically it can have there's a Moxie server running on each of the web application nodes, and the memcached client just goes to that server, and then the Moxie proxy takes care of all the magic. So we've still got all the benefits of using Couchbase, and it's persisted, and the clustering, and knowing where the nodes are going and coming, but that's all hidden for us behind Moxie. And that works really well for us. So if there are any Python developers who are struggling with this was the workaround we came up with, because in the absence of the other client, which I understand is under development, and hopefully we'll get to the level of maturity of some of the other clients soon. It's perfectly possible in this situation for the memcached client just to go through a load balancer onto one of the Couchbase nodes as well, if you wanted to do that rather than running the Moxie server, but it's up to you. The Moxie server just gets the configuration from the cluster by kind of looking at any changes in the topology of the cluster, etc. So this application, as I said, it's only kind of dark launched in a limited number of markets. There's not a crazy amount of traffic on it. We've benchmarked it to over 1,000 ops per second, and at that stage our benchmarking started failing. So we're not too worried about how well it can perform. It's just 3 nodes this time, and because the volume of data is quite a lot smaller than we have for the flights, we just kept it virtual for now. We can always turn it into physical servers later on if the scale of the application requires. And we actually use authentication on the buckets now, which you can do through the Moxie proxy. So Memcached supports the SASL authentication, so that's just fine. So what's next for us? I guess we're on a journey at the moment of moving the non-relational data out of the relational database. So for years we've just been throwing everything in there, but actually it doesn't really all belong there. And so we're taking things like reference data, which is just straight lookups about things where we don't do any aggregations or joins into one place. The one limitation with that is, so beyond that though, one of the other things we do at Skyscanner are these, as I said, these flexible searches. So if someone comes to the website and runs a search from London to Australia and just puts in entire months, the first thing they'd see is what's on the left. So the cheapest price it is to go to each of the airports in Australia. And if we clicked on the top link there, then you get this chart view on the right-hand side of how much it costs to fly out on each date and how much it costs to fly back on each date. So this is actually a really hard problem because there's 500 million or so quotes that it's searching through, and there's a lot of churn, so these quotes are being written very rapidly, fairly high read volume as well. And you can imagine that one of these aggregations is basically saying, okay, of all the quotes in there from London to Australia, which is the cheapest if we're pricing Australia from this price? So there's lots of crazy aggregations. And also, in our Windows 8 application, when you use search in Windows 8, you can search within an application natively. So we do some work in natural language processing where we turn a search expressed by a user, such as Edinburgh to Spain in July, the natural language processing parameterizes that into terms that we can then put into one of our search APIs. And that functionality is available in the Windows application. I think we've also used it to power voice search in the Windows mobile application as well. But of course, if you do that, that means people can enter the search at any level in the hierarchy, and they need incredibly flexible queries. So one of the things we're looking at using Couchbase for, and this is purely experimental, is actually using it to generate the aggregates that you need for something like this. So probably can't generate all the aggregates we need, but we could generate some of the highest level aggregates just using MapReduce views across the quotes data to pull out those individual points. So that's one of the things we're looking at. Something else we're looking at is an application which we can't talk too much about, but it's going to be much more of a classic database usage where nearly all the data can just sit on disk, just a small amount of it needs to be in memory, but we need it to be available across multi-data centers. So we'll use multi-data center replication to share those data around. Right now, the data are loaded into Couchbase from the Rabbit exchanges, and we can just shovel the data between those exchanges and data centers. But with Couchbase 2, we can just push the data, use a multi-DC replication in case a user kind of gets bounced around or we want to have documents everywhere. So on reflection, where have you got to? What's Couchbase brought us? Well, we've now got it's a default technology for us. So when we're starting a new project, it sits up there with the other core technologies we have. So it sits alongside SQL Server, and the first thing we ask ourselves now is, do we really need to use SQL Server, or are the data really relational? What makes the most sense? And we've done work with Solar and other things too in the past, so I'm not saying Couchbase will answer all the things, but it's one of our default tools to pick up. And it's helping us move relational data out of the database and look at a solution that helps us scale horizontally. And I guess we have to remember that these things are pretty new technologies. So in this implementation, as well as taking the softly approach, at the point of running only on the Couchbase cluster for our flights cache, we need to be able to handle the fact that it may just go entirely. And we put caching. Typically, caching layers are put in to make things faster or to reduce load on the back-end system, but if your cache goes, then you don't want to nuke the thing underneath it. So we need to make sure there are measures in place that we can degrade functionality for our users in a graceful manner in the event of the cluster going down. Hopefully it won't, but we need to be aware of that, and I think you have to just treat these things carefully and adjust to them as you want. And it's hard as well. So from a perspective of a database team, database administrators, may not necessarily know the technology or they may see the technology as a threat. And also for an infrastructure team, it's a whole bunch of new technology to learn how to use and take things in and out of the cluster. Now, thankfully, it's very easy to learn, but actually getting up to running a major production instance of Couchbase does actually take quite a lot of organizational change as well, in terms of the readiness of everyone to use it and be comfortable using it and operate it in a kind of safe way for our users, as well as the developer mindset change of, well, could I use this as an alternative to just throwing it in the database along with everything else? So these are our offices up in Edinburgh. So as part of our exponential growth, we need to keep hiring engineers. So if anyone here would like to, is interested in coming and joining us, it's a great city, the international festivals, really good fun, there's nice beaches and good hiking and things. And thank you very much for listening. I think I have a few minutes for questions, 5 minutes for questions if anyone's got any, so thanks very much.